So in this video, I will explain the idea of Z transform, and we will do one sample problem so that you understand how exactly Z transform works. Now, the first point that I want you to understand that whenever you're doing any transform, okay, you're basically converting it a time domain into frequency domain. Now, what I mean by that is, say if we are doing Z transform, then the time domain would be x of n. Okay, it's a time domain signal, and it will get converted into x of z. So the reason why I call this as a time domain is that n over here is time, and as you can imagine that in the frequency domain the z has to be frequency, and I also want you to note that it is a complex frequency. Alright, so z is a complex number. Now that's the basic idea of z transform, that when you have x of n, that is a time domain, and you take a z transform, you get x of z, that is a frequency domain. Just one point I want to make, that you can always go back as well. So if you want to go from time domain to frequency domain, you will perform z transform, but then you can always take a inverse z transform as well, and that will get x of z back into x of n. And for performing z transform, we have a standard formula of z transform. So let me write that as well. The z transform formula, you have to remember this formula. Okay, it says when you want to find out x of z, it is sum of n is equal to negative infinity to infinity x of n z raised to minus n. Now that's the standard formula, and we will see this formula in the action when we'll solve one question. So now I would like to take just one question so that I can explain things better to you. Now the question is going to be like this: find Z transform. Okay, that's the question. And let's take the first problem of that. Say if you have given x of n, and the value of x of n is say 1, 2, 3, 4. Now that's a standard example that I want to find Z transform for. So we will be using this formula and solving this question. Now first I want to explain to you how is this x of n going to be. Look, when I want to draw x of n, the horizontal axis is n, and this is the signal x of n, and well, these values are going to be 1, 2, 3 and 4. Okay, now that's the x of n, the given signal over here. I want you to just observe few things before we proceed, that when you have x of n, the horizontal axis over here, now this axis is n, right? Now in our case, in case of our signal, that is x of n over here, we clearly have n going from 0, 1, 2 and 3. These are the values of n, and the values of x of n are 1, 2, 3, 4. Now one next point I want to make is, if I want to write say x of n at say n is equal to 0, now just substitute that n is equal to 0 here. Okay, and you will get when I put n equal to 0 over here, now this will become x of 0. And what is the value of x of n at n is equal to 0? What is that going to be? The value of x of n at n is equal to 0 is 1, right? So that x of 0 is going to be 1. That's how we basically read the signal. It's quite obvious as well, but then I just thought I'll clear that up a little bit. Now once you have that, we can start solving this question. Now see how the solution of this problem is going to be. First we will have to use the Z transform formula, and the Z transform formula is over here, so I'll use that one. Okay, so by Z transform formula, let's write down the Z transform formula. It's going to be x of z is equal to, this is sum of n is equal to negative infinity to infinity x of n z to the negative n. Alright, now what happens here is, whenever you're doing the Z transform, depending on this x of n, okay, depending on the given x of n, you should choose the range of n. The range of n goes from, that way the formula has got the range of n going from minus into infinity, right? It's a full range you to take. But then in our question x of n, do you see our n will only go from 0 to 3. So what we'll do is, we'll take it this from 0 to 3. Now that's the range our x of n exists, because everything beyond that 0 and 3 range is going to be all 0. So you see it's all 0 over here after 3 and before 0 as well. Everything else is going to be 0. Alright, so n goes from 0 to 3. You put that value in this and execute this summation. Let's just see what we get now. So now x of z is going to be, put n is equal to 0. So this n equal to 0 value, I'll substitute in this expression here. Okay, and 0 gives me x of 0. This is x of 0, z raised to 0. Now put n is equal to 1, x of 1 z raised to negative 1, then x of 2 z raised to negative 2, and x of 3 z raised to negative 3. So I just like substituted the values from 0 to 3 in this expression, and I wrote plus because we are executing a sum here. Now you see we have x of 0 already available here. X of 0, the value of x of n at n equal to 0, and that value is just 1. So I write this value as 1, and when I say z raised to 0, that is also going to be 1. Then tell me about x of 1. If I want to find out the value of x of 1, that is x of n at n is equal to 1, and that is just 2. So now this value is going to be 2, and this value is 3 over here, and this one is 4. Okay, so once I get these values, I write down x of z again. Now this x of z, the first term is just 1, both of them are 1. Then next term is 2 z inverse, and then the next term is 3 z raised to negative 2, and then this is 4 z raised to negative 3. So this is going to be your x of z. Okay, so I got it right. This is the final answer. Now what happens in Z transform is you actually got the final answer, but then there is one small part that we have to discuss before we conclude that this as an answer. There is just one thing that I want to discuss before moving forward, and that is that this answer is pretty good, no problem. We have x of z already with us. Now there is only thing that at z is equal to 0. My question is, what if z becomes 0? All other values are fine. Okay, only when z becomes 0, do you see we have a term like z inverse? Okay, and that is just 1 over z. So when I say 1 over z, that's going to be 1 over 0, and 1 over 0 is going to give you infinity, right? So when z becomes 0, this thing will become infinite, and when this becomes infinity, now when this becomes infinity, this entire thing will become, the x of z will become infinity. Let me undo that. So this will give me x of z as infinity, and infinity simply means not defined, right? So what I'm trying to tell you is that whenever your z value will become 0, your x of z is just not defined. Okay, so you have to make sure that your z is not 0 for this to be your answer. Making sense? That if your x of z value is this, then you have to ensure that your z should not become 0. Why? What will happen if the z becomes 0? This answer will become infinity or not defined, and we don't want that, right? So now how do I portray that, or how do we write down? And there is a standard way to do that, and I'm just going to do that. Just see how it works. Uh, well, first of all, this over here is called as a complex plane, or I can say Z plane. Look, I've already told you that Z is a complex number over here. Can you see that here? The Z over here is a complex number. So this is a complex plane. This is a real axis, and this is imaginary axis. Okay. And when I say Z is equal to 0, Z equal to 0 is going to be this place over here. Okay, now that's the area. I'm just like exaggerating a little bit, but that's just a z equal to 0 is going to be at origin, and at this area x of z is not defined. It's not a good thing. So let me draw a side face for that, and that's going to happen only at z is equal to 0. But apart from that, for all other region of z plane, say over here, here, anywhere, okay, say here or here, all over the place on z plane, there is absolutely no problem. Okay, so I'm sorry, the last line has actually gone into this. Okay, so all over the z plane, from all the quadrants till really till infinity, all over, there is no problem whatsoever. You can find z transform, you can write down, you can take this as an answer, but except at this point, and then this shaded, the region, that the shade, the white shading that I've done, this region is called as region of convergence, or it is called as ROC. We are actually going to see the ROC in much greater details in the later video, but basically now about this problem, let me write down a few things about ROC. Now over here, that ROC is, do you understand, is except at origin. So you cannot have ROC at origin, but everywhere else there is no problem. And right now, can I say ROC is equal to good region? Why good region? What do you mean? But as at this point of time, I just want you to have the understanding of ROC as a good region, so that that's the area where you can actually find out the Z transform, or the Z transform simply exists. Okay, so I can just like draw a smiley face. So you have to ensure that you don't go to this non ROC region. Okay, non ROC region is simply is going to make your answers not defined, but then other than that, the ROC region is going to be a good region on Z plane. So this is basically a simple standard question of Z transform. This is how you can actually solve any problem of Z transform. I hope you followed this. You have to just remember this formula of Z transform as well. Okay, and that's it. So now we'll see the next one.